Okay, so in this video I'm going to be looking at cut capacity, how to calculate it, and also how to find the maximum flow. So what is cut capacity? A cut is an imaginary line across a directed graph that completely separates the source, which is the start of the flow, from the sink, which is the destination of the flow. If it does not completely separate the source from the sink, then it's not a legitimate cut. So here are two examples. Are the dotted lines cuts? Why or why not? So here in the very first example, here's our cut, and we can see it completely separates the source from the sink, the start from the finish. If you want to think about it like that, the source is the start, the sink is the finish. Okay, so just imagine the source is a tap, and the water flows all the way to the sink. That's where it ends up. So yes, this is a cut, because the cut, or maybe I'll just say because the line completely separates the source from the sink. If we have a look at the second example, you can see that here we've got our line, but does it separate the source from the sink? No, it doesn't, because we can see if we turn on the tap, water can flow through these pipes into the sink. Okay, so water can still get from the source to the sink. So, no. Because the dotted line does not completely separate the source from the sink. Okay, so what is cut capacity then? Now we know what a cut is. What is cut capacity? The cut capacity is the sum of all the capacities of the edges that a cut passes through, taking into account the direction of flow. The capacity of an edge is only counted if it flows from the source side to the sink side of the cut. So basically all we need to do is we need to add all the edges, add all the numbers of the edges that the cut goes through. But we need to make sure that we need to think about whether we need to add that number or not. Okay, by considering whether it flows from the source side to the sink side of the cut. So what do I mean by that? Here we've got a network diagram. Okay, a directed network. It's directed because it's got the arrows. And we want to find the cut capacity of the 4 cuts shown. Well, there's no cut shown at the moment. I'm going to draw them in. So let's say, for example, you know what? I'm going to draw a cut right here. And if you notice this, that if I were to cut a line through there, if I were to cut those pipes right there, no water will be able to flow from the sink, from the source to the sink. Okay, so it is a legitimate cut. So all I'm going to do is I'm going to add 15 and 20. So let's call this cut 1. The question is, do I need to add those numbers? It goes through 15 and it goes through 20. What I want you to do in order to practice this is to highlight the left side of the cut. If we were to highlight the left side of the cut, we can see that the start of this edge is here, and the start of this edge is also here, and they are both highlighted. Because we have highlighted that vertex for both of them, both edges, we add both numbers, 15 plus 20, which is 35. Okay, so the cut capacity of that cut is 35. But what if, let's get rid of these. I'll just throw them back in. What if I want to do a different cut somewhere else? Let's say I want to do a cut from here down here. Right? Can you see here how if we were to cut along here and here and here, it will definitely separate the source from the sink. Now we notice that it's crossing 3 edges. So you would think, you would think that the cut capacity would be 14 plus 6 plus 20, because it cuts those 3 edges. But we need to ask ourselves, we need to consider the flow of the edge. So I'm going to highlight everything to the left of that cut that I just made. Everything to the left of that cut. You can see here that the start of this edge is here. Hey, that's highlighted. Good. We add the 14. We can see that it cuts this edge and the start of this edge is here. Yes, that's highlighted. So yes, we add that 20. But if we notice, the start of this edge is over here. That's the start because of the arrow. The start of that edge is not highlighted in yellow, so we do not include that 6. That means the cut capacity of that is only 34. Alright, let me get rid of all this. Right, what if I want to do a different one? Let's say I want to do a cut right down the middle. We'll call that cut 3. We can see it cuts along 3 edges. Okay, but before that, I'm just going to highlight everything to the left of that cut I just made. Okay, well, it cuts along 3 edges. This edge, and this edge. Okay, so we can see that the cut cuts along these 3 edges. The start of the top edge is here. Good, that's highlighted. We include that 14. The start of the 15 edge is down here. We include that 15 because it's highlighted in yellow. The start of this 20 edge is here. So we include that 20. So in fact, we need to add all 3 numbers, which is 49. The cut capacity of that is 49. I know it looks quite messy when I'm drawing all this out. I apologize for that. I want to do one more cut, which is right here. Pause the video, have a go, and see if you can find a cut capacity of that cut. We'll call it cut 4. Okay, so you should have highlighted everything to the left of that. Right, highlight everything to the left of that. It only cuts through 2 edges, this edge and this edge, and the start of the top edge is here, and the start of the bottom edge is here. They're both highlighted, so we need to add both numbers. So we've got 10 plus 15 is 25. Okay, so hopefully you have a better idea now of how to find the minimum cut. Or to find a cut capacity, sorry. The reason why I've taught you how to work out the cut capacity is because we need to work out what the minimum cut is in order to determine the maximum flow. Okay, so, and we go back to this directed network here. The minimum cut is the last one that we did, 25. Because 25 is the smallest answer we get when we add the weights of the edges that is of a legitimate cut that completely separates the source from the sink. Okay, so at the very beginning, cut 1, we got 35. Cut 2 was less than that. Cut 3 was the largest. Cut 4 was the smallest. Now, our job in order to determine the maximum flow is to determine what's the smallest number we can get when doing our minimum, when we're doing our cut. When we're calculating our cut capacity, what's the smallest number we can get? Because the smallest number we can get, which is also known as the minimum cut, that is the maximum flow. So if I'm looking at this network diagram, I can see that, let's assume this is water, that 35 liters of water can flow from the source per hour. However, according to my calculations, the minimum cut is 25. That means only 25 liters of water can end up going to the sink, can end up at the destination per hour. So, like I said, the easiest way to find the maximum flow of a directed network diagram is to find the minimum cut. So, the table below shows the flow capacities of the edges of a network. Determine the maximum flow from S to T. I've already drawn a diagram here for you. Why don't you pause the video, draw this diagram out, and see if you can work out what the maximum flow of this diagram is. Remember here, this is the source, this is the sink. Okay, and when you're ready to check your answers, continue playing the video. Okay, so for me, this is what I like to do. I know that my cut always has to go through somewhere on the top and somewhere at the bottom, right? In order to completely separate the source from the sink, it needs to go through somewhere on the top and somewhere on the bottom. Now, if I'm looking at this, I can see that the top half of the diagram has 8 and 3. So I'm thinking, oh, you know what? It probably goes through the 3. The next thing I'm thinking is, it needs to go through the bottom somehow. And the bottom half of the diagram is 11 and 1. So, you know what? The smallest number there is 1. So it'll probably go through 1. Okay. Now my question is, how do I connect this to this one from here to here? And when I add the numbers, I get the smallest possible answer. So, let me see. I could do cut straight down here. If I were to cut that right there, and I highlight everything to the left, okay, highlight everything to the left, I can see it cuts through 3 edges. This one, where the start is highlighted. Okay, so I need to add that. This one, where the start is highlighted, so yeah, okay, I need to add that. And this one, start is highlighted, okay, I need to add that. I need to add all 3. When I add all 3, I get 9. Okay, so now I need to ask myself, is there a smaller answer I can get? So let's have a look. Let's try orange. So I know I want to go through here. I know I want to go through here. Let's try going through this way instead. let's do a cut that way. So I'll just call that cut 2. So I'm going to highlight everything to the left of that. Okay. Now we see it goes through 4 edges. I know I want to go through as least number of edges as possible, so I can get a smaller number. But maybe we won't have to count any of them, or some of them. The start of it goes through this edge. Okay, that orange cut, and the start of that edge is right there, highlighted. We add that. The start of this edge, it goes through this edge, and the start of that edge is actually over here, because if we're looking at the arrow where it's pointing, this is the start, and that's not highlighted, so we don't include that 3. Okay, it goes through this edge, start of that edge is highlighted. Okay, so I need to add that, and that's 3. And it goes through this edge, that orange cut goes through that edge, and the start of that edge is also this one, which is also highlighted, so I need to add that 1. And we can see here, 3 plus 3 plus 1 is 7, and that's probably the smallest cut, the minimum cut, and it is. So therefore, because the minimum cut is 7, the maximum flow is 7. Okay, so I know we're looking at this diagram and we're thinking, let me just get rid of all this. We're looking at this diagram and we're thinking, 20 liters of water can flow out from the tap. But in reality, only 7 liters of water will get to the sink. A maximum of 7. Okay? So let me just draw those cuts in again for you. The orange one is this, and the purple one was just straight down. Okay, I hope that helps.